Welcome to the PhotoModeler Curves and Surfaces tutorial. In this tutorial, we will demonstrate how to mark and create 3D curves and surfaces. We start with a simplified project to demonstrate the basics of curve marking, referencing, and editing. We have a piece of paper with 5 curves on it. The project has the initial targets marked and referenced, and the project is oriented and processed. One of the key things to consider with curve marking is that the photographs used to mark and reference curves have to rotate about the major axes of the curve or the curve segments. Here we have 2 photographs taken from either side of the piece of paper. We can see this curve is mostly vertical, and we have this curve that is mostly horizontal. The 2 photographs rotate about an axis that is close to the major axes of this horizontal curve, and so this curve would solve well on these 2 photographs. The vertical curve, on the other hand, would not, but we can use other photographs for that. We will start by making this curve. An open curve requires a marked and referenced point at one end of the curve, or both ends. We will start by marking a point here using the Alt Zoom. And then use Quick Reference to reference the 2 marks together. We'll then zoom in a bit further on the 2D curves so we have more accuracy in marking. And we pick up the Mark Curve tool. We start by clicking on the referenced point. And we move the cursor while watching the guideline. We click down on the curve. The key is to mark points close together when the curve changes shape rapidly, and then farther apart when it is more gentle. When we get to the end of the curve, we use the right-click mouse button to bring up the menu and choose End Curve Draw. We'll do the same thing on the other photograph, starting with the referenced point. We click along the curve, watching how our guideline accurately matches the curve in the photograph. Curves, like points, edges, and cylinders, are referenced objects. And so we'll need to reference this to make it 3-dimensional. We select the 2 marks and use the Quick Reference tool. You can see we have created our first 3D curve. We will mark another curve, a circle in this case, which is a closed curve. Closed curves do not require a shared starting point. We'll zoom in on the large circle in the 2 photographs. We can directly enter curve marking mode without marking any 3D points on the curve to start with. Similar to marking the open curve, we mark points along the 2D curve, ensuring our representation is precise and matches what we see in the photo, not just at the points we click, but along the curve line as well. When we are finished, we can click on the beginning point to close the curve. One thing you might find with closed curves is that when they close, the 2D curve redraws, and you have to review to ensure it still lines up with the photo. You can modify a curve by going into Select Mode and clicking on one of the curve points and dragging to change its shape. We can study the curve more closely by using the Alt Zoom to move along the curve and study each part to see how well the mark matches the photographic curve. We'll carry out a similar operation on the other photograph. We do not need to start marking the same place. We solely have to make sure the mark is precisely marked on the 2D photographic curve. Instead of clicking on the first point to close the curve, we will use another method. We can use the right mouse button to bring up the menu and choose Close Curve. We go back into Select mode and adjust the points to line up the mark with the 2D curve on the photo. Select the two curves and again use Quick Reference. We now have our 3D closed curve. We'll zoom in to look at this curve from the side. You can see that these small sections are a bit warped and not on the plane. This is due to the nature of the closed curve and that these parts are not perpendicular to the main rotation between the two photos. The curve algorithm has difficulty in these areas. You can add additional photographs to improve this, but we also have some curve properties that can help. We right-click and bring up Properties. One property we can change is whether the curve should be planar. We apply that and we can see that the curve now fits to a perfect plane and looks better. We can also make the curve a perfect circle. When it is a circle, we can use the Measure tool on that curve, and we get the circle's radius and its center in the project's 3D space. We'll look at the other curve now. This vertical curve. To do that, we'll need to open two other photos. We'll open photos 2 and 4. This is the curve that we are going to mark. We'll zoom in using the wheel mouse. Mark our required reference point at the end. Reference the point using Quick Reference. While we are marking this curve, we will demonstrate a few other capabilities. We'll start by marking this curve in the normal fashion, but we'll end the curve drawing too early. And on this curve, we'll make a few mistakes that will need some correction. First of all, one of the modifications you can make to a curve is to extend its length. We'll zoom in just a bit further. When you are in curve marking mode and you go to a curve point and click on it using the left mouse button, you'll get a menu asking if you wish to extend the curve or start a new curve. In this case, we'll extend it. Then we'll be able to mark new points as if we were marking the original curve. We'll do our usual cleanup to check the match to the photo. On the other curve mark, we have a number of problems. We enter curve marking mode. When we are in this mode, we have the capability of adding and deleting individual curve points. Let's delete a few of these points. We move the mouse over it and use the right mouse button when we click down. We get a menu and choose the Remove Point from Curve option. We'll remove a few of these. Then go back into Select mode and see if we can adjust the points to get better alignment. Here we'd like to insert a curve point. We go over the curve mark with the curve marking tool, and again use the right mouse button to bring up the menu when we click. We choose Insert Point in Curve option. The point will be inserted. We move the mouse to get the correct location and click down to complete. Then, as before, we select the curve marks and use Quick Reference tool. We now have our other 3D curve. We've loaded the done.pmr project to see the completed project with a couple of circles, our two curves, and a more complex curve that changes direction. Note that you can mark and reference a curve on multiple photos, in this case 3, as shown with this circle. This can improve accuracy of your 3D curve. In this introduction project, we have learned how to mark, reference, and edit our basic curves. With this next project, using a table lamp, we are going to demonstrate marking and referencing some real-world curves as well as the surface of revolution tool. The project has already been set up with targets that are marked and referenced. The project has been solved and one cylinder marked. You can see the 3D result of this preliminary work. We are going to mark a very small curve at the base. We have already marked a line from the cylinder to a point that has been marked on the edge. We'll pick up the curve marking tool and, starting with the existing referenced point, mark along this curved line. We repeat on the other photograph. We then reference them together using Quick Reference. And you can see the small 3D curve that results. We may need to do a bit of adjustment to the marks. And you can see the resulting curve. We'll now demonstrate the surface of revolution tool, which is a type of surface that revolves around an object. In this case, we'll revolve it around the center of this cylinder. To guide us while using this tool, we'll open the instruction bar by right-clicking on our top toolbar. It appears at the bottom and will give us instructions. We go into the Surfaces drop-down and pick Revolution Mode. You will notice that the instruction bar tells us to select a curve, edge, or line as the profile curve. In this case, the profile is the small curve we just created. Then it says select a line, edge, or cylinder as the axes of revolution. In this case, we want to use the cylinder to give us the surface of revolution. This surface is being created backward, so we'll quickly use the Flip Surface command from the list. We are going to create another surface of revolution using this line as the profile and the same cylinder as the axes. That wraps a flat surface around the base. Being backwards, we'll use the flip surface command. We now have our base created using a curve, a line, and the surface of revolution tool. We'll create a couple more of these surfaces using these lines and the cylinder. You can see the pieces at the top. Both have to be flipped. We have already marked on the light bulb a curve which is yet to be referenced. So we'll select it and reference it. We go back into surface of revolution mode, select it as the profile curve, and again the cylinder as the axis of revolution. We now have the basic parts of our lamp created with referenced curves, a cylinder, and surfaces of revolution. We've opened the project_done.pmr, which has the completed lamp project. You can see the two new photographs that look different from the first two. The target points on the bottom are the same and have been referenced together. The lamp was held stationary while a shade was added. This trick was used so we could model both the interior parts and the exterior parts of the lamp. Here we have the 3D view of the completed project. The shade was also created with a surface of revolution using this line that was marked on a seam as the profile. We have the shade in a different layer, so we open the options to turn that layer back on. You can see we have the completed model displayed. We'll then turn on textures. The shade was given a non-textured material and the base a textured material, and we have our completed 3D lamp model using curves and surfaces of revolution. In this project, we will demonstrate another method of creating curves called curve-through points. We also demonstrate some other methods of creating surfaces. Here we have loaded the project pointsline.pmr from the Ferrari subfolder. We have photos of a model car. What has been done so far is the project has been set up with a number of photos with points and lines and solved, but no curves or surfaces. You can see that on some parts of the model, target dots have been placed on curves, so we can reference the same point. Other points are marked on natural features of the model. We will start by adding some curves. To make this easier, since we will be using the 3D viewer, we increase the point size in the Options dialog. We will start by adding a curve to the bottom of the windshield. We pick the Curve Through Points tool. As we click on each point, the curve is created in 3D between the points. And when we are finished, we right-click and choose End Curve Draw. Our curve has been added. We'll do the same steps with two other curves. First, we'll do this fender line. To ensure we are picking the correct point, we use the 3D rotation for a better view. Similarly, we will create the wheel well. we've added 3 curves through points. Here we've loaded the project curves.pmr from the Ferrari subfolder. We have a wireframe car model with all the curves completed. We'll demonstrate a few of the different surface creation tools. The first one we'll use is called Boundary Patch. Boundary Patch is a NURB surface that takes 3 or 4 curves that bound the edge of the surface. A curve can include a line, as we used here. We use the 3 lines here. It draws the surface, but we want to complete it with this 4th curve. When the 4th curve is added, the surface completes, giving us a nice surface with the boundary of those 4 items. We'll do the same for the hood. One, 2, 3, 4, and then flip the surface. We then switch to a different surfacing tool called Loft Mode. Loft Mode takes 2 or more curves and produces a lofted surface through them. Here we'll use these 3 curves and lines on the front of the car. We select the first one, the second, and the third. Because a loft surface can be made up of many curves, we need to right-click and pick Finish Surface. The next surface type we will use is called Path Surface. A path surface is similar to a boundary patch surface, but it can take more than 4 curves, but is not quite as accurate at the bounds. When we have more than 4 elements in the boundary of a surface, we need to use path surfaces. We start by selecting our segments in order. The red path shows the complete boundary, and we have our completed path surface. Lastly, we'll show the surface of revolution. We'll do the wheels. The wheels were marked with a small line from target dots, and the axle was from 2 other marked and referenced points. We pick the revolution tool. Pick our profile curve and our axes of revolution. Similarly, for the front of the wheel, the profile curve and the axes. We have our completed wheel. We've now loaded the done.pmr project. You can see the completed surfaces of various types, including the bottom, the back, and the wheels. Lastly, we'll show the display with textures. And then quality textures. We now have our result. Further fine-tuning could be carried out on the texturing so that certain surfaces were assigned to particular photos to improve the balancing. This concludes the Curves and Surfaces tutorial. In this tutorial we have learned how to mark, reference, and edit curves, how to create curves by fitting through 3D points, how to create surfaces by revolution, boundary patch, and path mode.